Hello and hi everyone. I'm Farhana Sadat, Assistant Professor in the Department of Computer Science. In this section, we are going to see about process management. Let us see what is the concept of process. A process is nothing but a program in execution. Usually, the process that will get executed must be progressed in a sequential order. For example, we can say that a process is an active entity as opposed to be a program which is considered to be a passive entity. The attributes that are held by the process may include hardware state, memory, CPU, etc. The process memory is divided into 4 sections for efficient working. The first one is the text section. It is made up of a compiled program code read in from the non-volatile storage when the program is launched. The second one is the data section. It is made of the global and static variables and allocated, initialized prior to executing the main. The third one is a heap, which is used for dynamic memory allocation, and it is managed via calls to new, delete, malloc, free, etc. And the fourth one is the stack, which is used for local variables. Space on the stack is reserved for local variables when they are declared. The next is process state. As the process executes, it changes its states often. For example, there are 5 states available: a new state, running state, waiting state, ready state, and terminated state. What is a new state? The process is being created is called as a new state. Then running state. The instructions are being executed that are held in the running state. The process is waiting for some event to occur means that it is in a waiting state. If the process is waiting to be assigned to a process, then it is called as a ready state. And if the process has finished all its execution successfully, then we call that as a terminated state. Look at the diagram here. All the process are being created, we call it as a new state. So when it is admitted, that is ready for execution, everything will be put into the ready state. And the possibilities is when it is started, as per the schedule, when it started running, there may be chances of getting successfully completed process. Then we call that as a terminated. So once it's completed successfully, it will enter into the it will exit, and we should be sent to the terminated states. And other than that, during the running process, there may be a chance of getting some other things. Maybe sometimes some interrupt may occur. In such a case, so it will complete its request and then again go to the ready state and started running, and then complete, then terminate. Otherwise, it may request IO or some event may occur. Then it automatically enter into the waiting states. So once after the waiting state, it can be again sent to the ready state for completing its executions. The next one is the process control block. There is a process control block for each process which encloses all the information about the process, and it is a data structure which contains the following details like process state, program counter, CPU registers, CPU scheduling information, memory management information, accounting information, IO status information, etc. A process state which shows the current state of the process. That means it indicates whether the process is in a ready state, running state, waiting states, or whatever state. It just shows the status of the process. Privileges. What is privileges? It is nothing but giving permission, that is allowing or disallowing the access to a system resources. Process ID. It is an unique identification for each of the process, which means that no two processes can have a same ID. Pointer. It points to the parent process. Program counter. Actually, it is a pointer which holds the address of the next instruction to be executed. CPU register. There are several CPU registers available where the process need to be stored for execution for the running state. CPU scheduling information, which holds the details like the priority of the process and other scheduling informations which are required to schedule the process. Memory management information, which includes the information of the page table, memory limits, segment table, depending on the memory used by the operating system. Accounting information, which includes the amount of CPU that are used for process execution, time limits, and execution ID, etc. I/O status information, it includes a list of I/O devices that are allocated to the process. This diagram shows how the CPU switch from one process to another process. See here we are having two processes, P0 and P1. So at the beginning, that is when we call it as a new statements. When a process is being created, then we call that as a new state. And when it is ready for execution, that will enter into the ready state. Okay, that is when the P0 started executing, P1 becomes idle. So during the execution, that is a running. So if any interrupt or system call occurs, it will automatically save the state of the process P0, that is the old state of the process P0 into a PCB, which stands for process control block. The 0 indicates the process P0 and 1 indicates the process state for the P1. So what will happen? So again, when it reload the state from PCB1, now the process P1 get executed. At that time, P0 becomes idle. Okay. So again, if any interrupt or system call occurs, which will save the state of the process into the PCB B1, and once after reloading the state from the PCB 0, that process P1 gets idle and P0 gets executed. So this is how the CPU switches from one process to another process.